Okay, recording now. So don't say anything bad because it's all going to be on record. Um, yeah, so my point was Kahneman and Tversky wrote this article, published it in a good journal, general interest journal called Science. And their goal was to sort of revolutionize the way people classified these errors that people made when they're thinking about judgments. They're thinking about probabilities. They're thinking about how should I behave in this situation? I'm not that familiar with it, so I have to sort of come up with my own estimate of what the situation is like. And there's some systematic errors in this. And so today I want to talk about three things. And the three things aren't, so I actually, they're almost three categories, right? It's not that there's these three effects and that's it. That's all I want to talk about in terms of psychology. It's actually, there are many, many effects, but they are categorized into these three heuristics that people might have. So we should talk about what a heuristic is. You guys know what a heuristic is? It starts with an H. Kind of a silent here. Let me write this. Heuristic. It's kind of a hard word to define. Some people say it's like a rule of thumb or like a simple rule that you use to think about something or do something. Instead of as opposed to, let's say, a complex algorithm. You know, a complex algorithm would be, oh, I have to first think about this and then use all this information and put it together in a difficult and mentally taxing way to arrive at some conclusion. That would be, you could model human beings that way, but I think we all know that we're not that smart. We don't have the machinery to evaluate probabilities and other judgments using a complex algorithm for this is how it works. What do we do instead? We have heuristics. So how should you think about heuristics? Think of them as simplified rules, a simpler way to think about some problem that you can arrive at a simpler answer. Game theory has these too. You guys ever study game theory? Some of you may have. One heuristic would be if I like my payoff I'm playing a repeated game, and so if I think my payoff is good this round, I'll do the same thing next round. If I think my payoff is bad, I'll switch and just try something else. You're not even thinking about the game in a very complex way. You're not thinking about the strategic interaction between yourself and the other player. You're only just using a very simple rule, which is my payoff above, 10? If I get a payoff above 10, I'll just continue doing the same thing. If it's not, I'm going to try something else. And that's what a heuristic is, a simple rule. Another one was like, if you want to know the temperature outside and you just, converting Celsius to Fahrenheit, rather than thinking exactly what it is, you just think, 20 is room temperature Celsius and 70 is room temperature Fahrenheit. So 20 is about 70. You're not actually calculating the one for the other. You're just using the rule of thumb. Okay. I want to give you some of the original things that Kahneman and Tversky gave their subjects. They were experimenters. They actually did human subjects experiments. And let's talk about, I have so many I could give you. I think let's first, I see 4 of you with videos on. The rest of the class, no, you don't have your video on, but I want you to not use Google right now. I'm going to ask you a question, and I don't care about you getting don't ask Siri or what is it, Alexa, to give you the answer. Although I know in 2020 we all have this technology readily available. If I ask you a factual question, you could really answer it. Really. So here's the question. That's not important. Let's decide as a class. Is the Mississippi River from its source to its mouth, so the source is up in Minnesota somewhere and it goes down to Louisiana, the Gulf of Mexico, is it longer or shorter than 3,000 miles? So everyone in the chat, if you're available, just say, do you think it's longer than 3,000 or shorter than 3,000 miles? Don't look it up. Somebody said longer. I see four shorters, two longers, and six, uh, eight. Shorter seems to be winning. There's three longers and eight shorters. Three to nine. Most people are saying shorter. Okay, don't look this up. I hear clicking. Somebody's clicking. You're not looking it up though, right, James? You're just clicking.
No, I'm not. I'm
Okay.
not.
Okay. Okay, that's fine. Most people say shorter. I'm just looking at and I'm seeing that most people say shorter. Okay. Now I want us to think about what is the actual length. What's a guess?
Between like 750 and 1,000 is my guess.
Give me one number. Don't look it up. Just guess. Right now we're just like ballpark. Like what is the length of the Mississippi River? It's such a hard question because we don't really have any reason. It's not like we're going to travel from one end to the other. It's not like a car trip where you're like thinking, how much gas do I need and something like that. Somebody looked this up. Brody, I'm looking at you. It's like when Bart Simpson tries to forge his grades and he turns them into A's. He should at least make it plausible. Don't forge the A. You could have said, talk about 2,300 about. Is he right? Is 2,348 right? Okay. Yeah. Okay. So might be. Okay. So here's the thing, because I started you with 3,000. That was the first thing I asked. It turns out if you do this, people tend to guess things close to 3,000 after you ask that. Somebody said something pretty low, down to like 750. But the answer, actually don't know the answer. What is the answer? Is it 2,348? If you just type in length of the Mississippi, what does it say? Yeah, 2,348. Gosh, I should have started with the higher number. I apologize for that. Where are you? There you are. Okay, so if you ask first this question about 3,000, people tend to guess kind of near 3,000. And if you instead of starting you out with 3,000, I said, do you think it's shorter or longer than 1,000? And people would try to guess about that. Is it longer than 1,000? Most people would probably guess it's longer than 1,000. They're not sure, but more often than not, people would guess it's longer. But then their second guess, which was exactly how long the river is, would be a lot closer to 1,000. This is the type of experiment that I could really only do if I split the class in two and give some of you the initial guess of 1,000, the other one the initial guess of 3,000. But I will say this, I've done this in previous classes. I didn't do that in this year's class. I've done that exact thing where half of you, I'm going to introduce this term now. It's called an anchor. So imagine there's a boat in the water somewhere, and it's dropped an anchor. So I think everyone probably knows what an anchor is. It goes all the way down to the floor, the seabed, and kind of grabs onto the sludge and the dirt and rocks at the bottom of the sea. Maybe it's a lake. Maybe it's not that deep. I doubt you could do an anchor in ocean. It's too deep. So there's a lake, a pier somewhere where a boat can be anchored, and it's not that the anchor and the connection makes it so that the boat can't move. In fact, the boat can still move when it's anchored. It just can't go too far. So the whole point of an anchor is if your boat is here and you drop the anchor, you can move, but you can't move too far. And if you try to go even further, it slows you down. It drags you. And Kahneman and Tversky had this idea that that's exactly how the human mind works when they're making judgments. When somebody asks you about the Mississippi River, you don't know how long the Mississippi River is. But if your first exposure is in the form of a number, like I said, 3,000, I said, is it longer or shorter than 3,000? You in your mind had to think about that. Maybe you weren't sure, you had to guess. That's fine. That's what I wanted you to do. But regardless, that 3,000 served as an anchor for your estimates. That means in the future, the second question that I asked you, exactly how long is the river, it was affected by that anchor. Because the first number that you considered was 3,000, that meant the true judgment that you created was closer to that 3,000 than it otherwise would have been. Because it's like I dropped an anchor, your mind dropped an anchor at 3,000, and then maybe you thought, well, it's less than 3,000, so I'm going to go down. But you don't go that far down. Um, I gave you the less interesting one. If I gave you the lower anchor, it's actually better. You can actually see people don't stray. I gave you 3,000, and some people went down to in the hundreds. But even though it's in the thousands, it's close to 2,000. If I had given you an anchor in the hundreds, I think a lot of people would have guessed more answers in the hundreds. Some people would have gone into the thousands, but I don't have proof of this. But I do have evidence from previous classes, and I'll show you that later. But I do want you to know that one of the three biases and heuristics is called anchoring. It used to be called the anchoring bias. In fact, I think they call it the anchoring bias. But now they often drop the word bias and they talk just about anchoring as a process. That when you are making judgments, the first exposure you have to some topic serves as an anchor for whatever it is. And every future, when you consider more pieces of information after that anchor has been dropped, it's all processed in your mind relative to that anchor. So, okay, I'm going to type in maybe you've seen this already. Have you read this? What if I type this math problem and these asterisks are stars? I say, look at the chat and see that number and guess how big that number is. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. How big is that number approximately? Don't use Google. 40,000 approximately. It's a good guess. Yeah. At least 100. Well, definitely. It's definitely at least 100. It's 8 factorial. 8 factorial is a great answer. So this was another example Kahneman Traversy gave. Brody, you're always with the... Okay. And so their hypothesis was when people see these numbers and they're multiplying them together, you start with an 8, and then you see a 7. Maybe you go to 56. Then you get to the 6. 56 times 6. Gosh, I don't know. But you've been anchored with an 8 as the first number you see, and you kind of guess big. You overestimate the size of that. Whereas if you give the same problem but with the numbers reversed, for some reason this works. People, if you give them this order, starting with the 1, people underestimate the size of this product, of this factorial. And the argument is, well, we're English readers. We read left to right. So when we see 1 times 2 times 3 times 4 times 4, we start with 1 times 2, that's 2, times 3, 6, 24. You're already sort of thinking this is going to be a relatively small number because the first few numbers are small. You might say, well, any rational person would just think all of the numbers are being multiplied together. It doesn't matter what order they're in. Yes, that is an irrational, algorithmic way to think about it. But if you're using a heuristic, which is just, look at the first few numbers you see and assume the rest are going to be like that, then of course you're going to overestimate the product when it starts with 8 and underestimate. So that's 2 examples of anchoring that were given. But that's Okay. Do you guys have any questions about what anchoring is? I kind of feel like not using my slides. I don't know. I just like talking, but maybe I do need some slides just for some reference. I'll go to those later. Any questions about anchoring? Um, and so far, it's really just been about judgments. How do I judge the size of something? In fact, I've just asked numerical judgments, but it's amazing how many different aspects anchoring has an effect. Are there methods to overcome anchoring thinking? Well, sure. The more aware you are of it, the less you will be affected by an anchor. Um, it can be something. You may have heard of priming. Priming is a little bit related to anchoring. It's more psychology. It's deeper into psychology that you can be primed into thinking something almost subconsciously. I'm not so much talking about that. I'm not really talking about your subconscious mind here affecting you in ways that you don't realize. I'm really talking about the process of coming up with a judgment about something. I said, how, you know, um, let's go to what really matters here is how much you value something. How much do you value something is a judgment. It's probably based on preferences too, but economists really care about this effect, this anchoring effect, because it can actually have a demonstrable effect on your value, your willingness to pay for something. And what you guys could probably think of some pretty easy examples of this, right? Prices. Prices are um, you use that information, don't you? Have I told you the story of the black pearls? I don't know if I've said this story yet. It's also in the book Predictably Irrational. If you look at if you there's a chapter in Predictably Irrational about anchoring essentially. But I want to tell you the story that Dan Ariely tells in this book, and that is there was a guy Salvador Asale, I think is his name, who was in the jewelry business. He actually sold pearls, and one time he was traveling in the South Pacific. He went to a place near Tahiti and was told that in this particular group of islands there were these black pearls. They didn't look like normal pearls. They were very very similar except they were black in color, and the locals there uh, didn't value them as a precious jewels, a precious anything. In fact, sometimes they were used like gravel. Like if you want some fancy gravel, take these black pearls and crush them up, and now you have some black gravel if you want it. But this guy had an idea that says people in the United States, they don't know what these black pearls are. Here's what I'm going to do. I'm going to buy up as many black pearls as I can get here in the South Pacific. Then I'm going to take some of them back to New York and really really high profile jewelry store. I'm going to also put some ads out for them, but I'm going to take the black pearls and put them right next to regular pearls and some diamonds and rubies and other precious gems, and I'm going to put a really high price tag next to them. People in the United States don't know that these things are just used as gravel in the South Pacific because they're so common, they're everywhere, and people just don't care about them. What his idea was, because people have no prior experience with this particular product, he wasn't thinking about anchoring, but he was anchoring. He used anchoring in the form of a price to set people's minds for how valuable these black pearls were. I wish I knew exactly the price. It was like, $1,000 for a pearl or something, you know, whatever comparable to rubies and other rare precious gems are. Did it work? What do you guys think? Do you think people's like, that's not worth that much. I'm not paying that much for black pearls? It worked. Yes, it did work. You guys are right. He made a ton of money. He's known as the Pearl King. Now people are dumb. You could say people are dumb. We're gonna have this conversation that I think Peter and I've had this same debate before. Like, are people dumb or are they just simple in the way they process information they need to know? Because if you think about it, you can't go through your life looking at every possible product that you might buy and doing your own calculations about exactly what the worth of this thing is to your life and to your needs. What do? You use some heuristics. You simplify it and you think, in my best guess, how much is something like that worth? How much would I like to have it? How much could I sell it for later? Maybe you're thinking of that too. But you definitely simplify the process. And that's exactly why something like anchoring works. The reason something like anchoring works is because if it's your first exposure to it, this is like the first piece of information you have about black pearls, and that's they cost $1,000 per pearl. What do you do with this information? Of course, maybe you're thinking that that you say they're dumb. Maybe you're thinking that they're sort of naive, right? Or that they're easily tricked. Vapid. Ooh, that's rough. You don't have a very high opinion of your fellow humanity. Um, okay, so let's stick to the story and give you my interpretation of it, and that is anchoring doesn't just work when you're trying to judge something like the Mississippi River that you don't really care about the length of the Mississippi River. Anchoring also works when it's your life and your preferences and your money that's on the line. You are making judgments all the time about your life, and anchors can affect you. And it's just one of these three biases. I think okay. I have a video about this. I have a video about anchoring in judgment and also anchoring in what is the word that I use? Judgment and consumption or preferences.
Demand.
Demand. Thank you. That's actually combining consumption and preferences and demand. So your demand for thank you. Have you watched that video? You have. Oh, great. So you knew all this stuff already. But anchoring for demand is exactly that. That how badly I want a product and how much I'm willing to pay for it is affected by anchors. The other story that is good for anchoring is an experiment, and this experiment was also done by Dan Ariely, and he used his students and their social security numbers as an anchor. So he said, take you guys are all in my class right now. You don't have to do this, but let's pretend I told you all to write down your last two digits of your social security number and put a dollar sign so that you have a two-digit price for a bottle of wine. And so then I show you a bottle of wine and I read you the reviews and say, hey, actually, this is a really nice bottle of wine. At least that's what the critics think. Let's pretend you're all 21 years or older. And because I believe he did this in a graduate level class, people were 21. And so then the question was, these two digits of your social security number, they have nothing to do with you and how badly you want wine. It's random. We can all agree that there's the last two digits of your social security number say nothing about you. The question was, do you want to buy this bottle of wine for your price? If your digits were 8 and 7, that says, would you like the bottle of wine for $87? If your last two digits were 2 and 1, then the question was, would you like to buy this for $21? Of course, the people with the lower social security numbers had lower prices, and they were more likely to say they wanted to buy the wine. That's not it. That's not the study. What the interesting thing is what came next, which was saying, okay, I'm not actually going to sell it to you for the two price that you gave before. Now I want you to tell me what's the most you'd be willing to pay for it. Give me the maximum you'd be willing to pay, and so the way that he made this happen is said, okay, I'm going to choose a random number, and then if it's above the price you said you'd be willing to pay, you won't buy it. But if it's below the price you'd be willing to pay, then you will buy it. And that's how we made sure that this was a real decision. It wasn't hypothetical. People had to actually say, what's the most they'd be willing to pay to buy this wine? And here's the remarkable thing. The people with higher social security numbers were willing to pay more for the wine than the people with lower social security numbers. What? What does social security numbers have to do with how badly you want wine? It doesn't. But anchoring does. Because the people with the higher numbers already had to sort of consider whether it was worth that higher number, they dropped an anchor in their brain. So when they had to decide how much do I really want it, it slowed down their just like an anchor dragging along the ski floor. It affected how much they were willing to pay for it, and the effect was like $10. Right? If you took the top group, or I have stats on this. Maybe it's time to look at. There this. Okay, so I skipped ahead. Here's anchoring. Okay, enable editing, slideshow. Maybe anchoring is my favorite one to talk about, so that's why I talked about it first. Cool. Current slide. Okay, anchoring bias. I've told you about this already. Yeah, so when I did this with the Mississippi River, I gave students either the high anchor or the low anchor. The ones with the high anchor, on average, guessed the River was 2250, which is actually really close to being right. That's what happens with the high anchor. But the people with the low anchor, on average, they guessed 600. It's a big difference. Okay. I think I gave you every information on this slide. Let's look at the next one. This anchoring effect for consumers, it's almost like anchoring in demand. In this Dan Ariely experiment I just described, it's a difference of $10. People with the higher Social Security numbers on the top half were willing to pay approximately $10 more on average than people with the lower half. And that is just something that, a standard economic argument, how could you possibly explain that? How could that be their preferences? Is this really an argument about their preferences changing? No, I don't think so. There's no reason for people with a higher Social Security number to prefer wine more strongly than people who don't. You can only explain it with anchoring, and anchoring almost as a heuristic, as just a simpler way to think about how much something valued. I've done this with VCU basketball tickets, and it worked. It worked pretty well. Like the people with the high anchor were willing to pay twice as much as the people with the low anchor, but almost nothing I've ever done has had this bigger effect of this free year of Uber rides. Let me explain this experiment that I did. I actually did this. I didn't give people the free Uber rides. What I said was, how much would you be willing to pay for a 12-month service where you can use Uber anywhere you want and it's paid for, as much as you want, every time you ever want to be taken from one place to another, as long as there's an Uber driver who's willing to do it. And the Uber driver will still be paid like they would normally would. It's just, you don't have to pay anything. And the question was, how much would that be worth to you? Well, first I said, is it worth, would you be willing to pay $1,000 for it if you got the high anchor? I might say, would you be willing to pay $20 for it if you got the low anchor? And then after I asked that, I said, what's the most you'd be willing to pay? The people with the high anchor were willing to pay $500 on average, which was way more than people with the low anchor. This was random. Whether you got the high anchor or low anchor was just randomly determined. So the only way to explain that difference is due to anchoring. And I think there's a reason anchoring worked really, really well for this. It worked for the basketball tickets, but not as well as it did for the Uber rides. Do you guys have any hypothesis? Why did the anchoring work even more powerfully for the Uber rides than it did for the basketball tickets? Anybody have any thoughts? I have a thought.
I think.
Oh, go ahead.
I just think that we have less of an idea of how to estimate the Uber rides. Like for us, the season tickets, we can kind of quantify that a little bit easier. Whereas Uber, like we don't know how many rides we're going to take, whereas a season only has so many games.
Perfect. This is Fergus, right?
Yeah.
Thank you for the comment. I totally agree. This is about the different levels of exposure we have had with respect to our preferences regarding these objects and our how much market experience we have with it. Right? We know how much season tickets for basketball games go for approximately. Some of us are students and probably get them for free, but regardless, you have an idea for how much those tickets cost and how much they're worth. Some people actually go to these games back when we used to have basketball games at VCU. Whereas the free Uber rides, there's so much to think about. Like, wait a second, am I gonna? How often will I be somewhere where I just want to take an Uber ride? You know, how far will I want to go? Will I want to take a trip to New York? Is someone going to drive me all the way to New York City? There's so much like uncertainty and inexperience. Inexperience is the key. You have so little experience thinking about this particular product that the anchor effect is even stronger in that. And that this first piece of information, which should be irrelevant, the first piece of information is, are you willing to pay $1,000 for this service? Somehow that affects your how much you think it's worth. It's like, well, you know, maybe it is worth 1,000. You're starting to imagine cases where I could get $1,000 worth of usefulness out of this. And if it's the low anchor, you're not thinking of it that so much. Okay. I think I've said enough about anchoring. Unless you guys have any other, I did make 2 whole videos about it though. So go ahead and watch those 2 videos if you want to see what the me of the past said about anchoring. Let's talk, I'm gonna stop sharing again. I like to just talk to you guys. Let's, oh, why did I stop share? No, I take it back. I want to show you now a profile of a person that, let's go all the way up to here. A profile of a woman named Linda. She's fictional, she doesn't really exist. But can we all see this? Let me describe for you this profile of Linda from 1974 paper. Linda is 31 years old, single, outspoken, and very bright. She majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice, and also participated in anti-nuclear demonstration. Okay, so you know something about this woman, Linda, but you don't know everything. I have a question for you, and I'd like if you guys would please answer in the chat. I'll actually maybe pose it in the chat too so that you can see. There you go. Oh, somebody's answering a different question. Okay. Which of the following statements is most likely to be true? Okay, I'm going to give you 2 statements, statement A and statement B. And all I ask you to do is either give me an A or a B to see which of these is most likely to be true. And I'm talking about Linda right now, this 31-year-old woman who's bright, outspoken, and concerned with social justice. Which of these statements is more likely to be true? And please answer if you're willing to. A is that Linda is a feminist bank teller. She's a bank teller and identifies as a feminist. That's a feminist bank teller. Is that more likely, or is B more likely? And B is the statement, Linda is a bank teller. Okay, so which is more likely to be true, A or B? I'm seeing a lot of B's. I see an A, Brody. I see a lot of B's. Remember, A is that she's a feminist bank teller. James privately sent me an A. I don't know why you want to be public about it. You know, gotta go with something. Let people know. Don't be afraid. Most people say B. A few people say A. I think only like two people say an A. Almost everybody's saying B. So the statement is which is more likely to be true? Linda is a feminist bank teller. Remember, she's concerned with anti-nuclear stuff, discrimination, social justice. She's deeply concerned with that, with discrimination. She's a philosophy major. Okay, but everyone except for two is saying B. So let's hear from both sides. The people who say A, do you mind just answering why do you think it's A? Before we delve into this, both are definitely. How would you know she's a bank teller? You can't tell she's a bank teller. Okay, but
Yeah, just to chime in, it would have been easier to convince me that she's not a bank teller than a feminist, because part of the question kind of delved into the fact that she was like very outspoken about social issues
sure.
and like kind of cared about things. And like when I think of a philosophy major, I think of someone who probably doesn't care about money or doesn't care about the systems that we regard money in America.
Okay.
So like the bank teller was that was the thing that I didn't want to pay attention to.
Okay.
And I really wanted to account for the
Yeah. So James, you're saying A because she sounds really much like a feminist, right? Yeah, and you're still going with A, right? Michael's switching to A, and Brody chose A. So there's three people chose A, and I just want to hear from you why. And I believe James gave this answer. Brody, did you give an answer for why? Or Michael, why do you switch? Is it because she really sounds like a feminist? B is included in A, but I still think A is true for sure. Remember, what I'm asking right now is which is more likely to be true? The statement that Linda is a feminist bank teller or the statement Linda is a bank teller? It's 119. I saw the just, but you understand this isn't about certainty. We can never be sure. What happened? Uh-oh, hope my internet didn't die. Okay, it's back. Whoops. I want to show you this. Okay. I'm going to get to you, Peter. I wanted to hear from the people who said A, and I think I've heard from them all they're willing to say. The people who think it's A, the reason that they think that is because Linda sounds very similar to the description of somebody who's a feminist, and that's right. She does. That was intentional. And so because feminist is included in A but not in B, people may think, well, that means she's more likely to be A. She sounds similar to the group of people that are in A. She doesn't really sound similar to this group of people who are bank tellers. And I totally agree with that. If you stopped there, I would say, yeah, I agree. Linda sounds, and there's this word here that I want to use, representative. So Linda is very sorry. Is she representative? I think so. Is very representative of a group of feminist bank tellers. If you thought about, here's a group of feminist bank tellers, Linda probably sounds like she would fit right in with that description. Whereas if Linda, she's not very representative of bank tellers in general, because probably a lot of bank tellers are just kind of, they don't, they're just regular people. They don't particularly feel strongly about any political thing in general. I would agree with that. Here's where now I want to hear from the people who support B, and Peter has given a definition, a logic for why it's B. Do you want to explain? Can you unmute yourself and just explain using your words why it's B?
Sure, because B contains only one variable, is a bank teller, whereas A contains
is a bank teller and also the subset is a feminist, so it narrows the range even more. So B would be more likely because a wider range of possibilities is accounted for.
Does that make sense? Do you understand what he was saying? I agree with him. I agree. He gave, what was that? He was giving it in terms of, he said narrow, I think. He was talking about the set of people or the variable. He called it variables, that B was one variable, which is a bank teller. Are you a bank teller or not? You can think of that as a circle, the entire circle of people who are bank tellers. If Linda's anywhere in that circle, the answer to B is yes, she is a bank teller. Whereas when he used the word narrow, I sort of agree with this, because however large the set of bank tellers is, the set of feminist bank tellers has to be smaller, doesn't it? It can't be bigger, because you're narrowing it, you're narrowing down the description from all bank tellers to just some bank tellers. Of course, there are fewer people in that, and one is a subset of the other. He said, I think he made that argument too, that it was B. He said B contains A. I totally agree. The set of people for whom B is logically true is contained inside of, wait, B contains A. Is that what she meant to say? Oh, in other words, if A is true, then B has to be true also. That's what you mean. If A is true, then B has to be true also. So B contains those cases where A is true. It also includes other cases that A is not true. And that is correct. Right, so this question actually did have an answer, just like the Mississippi River had an answer. And that is B has to be, it must be more likely that Linda is a bank teller than a feminist bank teller. And there's a word for this, and that's called, it's the conjunction of two events. Feminist bank teller is the conjunction. That's just a logical, that's just a word that the people who talk about logic use to mean and. Conjunction of two events means they both have to happen. It's this and this. So a feminist bank teller is the conjunction of being a feminist and being a bank teller. And it's always more likely that, it's always less likely that a conjunction of two events is true than one of the two events. And therefore, this is called, the reason I use the word conjunction is to explain this next term, it's called the conjunction fallacy. The conjunction fallacy, which I just put in chat, that is the fallacy that says you may actually be more likely to think Linda is a feminist bank teller, which is the conjunction of two events, than she is for just one of the two events, bank teller. Kahneman and Tversky are very aware of this. In fact, they show that a majority of people fell for this conjunction fallacy. You guys didn't. You guys are smart. You probably saw it coming. You know, because almost everybody, not almost everybody, I would say 80% of you chose A. Chose B, which was the correct answer. So just a few of you chose the wrong answer, but you're believe in equality and not be a feminist. What? You're primed to look out for logical fallacies. That's exactly right. And before we did this, I told you, Kahneman and Tversky talked about three heuristics or three biases, and we talked about anchoring. That one's done. So this one is called the representativeness heuristic. Let me type that. So the reason that you may believe Linda's more likely to be a feminist bank teller is because of the representativeness. It's got so many syllables in this word. I don't know why academics do this. They take words and they just keep adding syllables to it until the word gets longer and longer. But the word is representativeness heuristic is one way to explain the conjunction fallacy, right? Oh, I didn't define for you the representative heuristic. Let me define for you on screen. Here we go. Oops, I'm talking about Emily. I'm probably going to skip the one about Emily. have some more time. Maybe I will. The representative heuristic is that we believe that something is likely to belong in a category if it is representative of most things in that category. That's kind of the definition of the representativeness heuristic. And it's just a mental shortcut that works pretty well most of the time, but it didn't in the case of the example of Linda. It also wouldn't do it in the case of this. Imagine an Emily who's introverted, and you know that most librarians are introverted, but most teachers are extroverted. And I told you, okay, Emily is somebody whose profile we're looking at, and she happens to be introverted. Is she more likely to be a librarian or a teacher? The representativeness heuristic says in our brains, we look at what we know about this is hypothetical. This hypothetical person, Emily, she seems to be introverted, and that's more representativeness of librarians. So probably Emily is a librarian. That's what we would be sort of primed to think because of the representativeness heuristic. But that would actually be wrong. The reason, and I mean, here's this example you can read on the screen, but the thing is there are more teachers than librarians. More people are non-librarian teachers than librarians. So just because you know Emily is introverted, that doesn't mean she is more likely to be a librarian. She's actually still more likely to be a teacher. Let me check out this chat. Yes, this is an insensitivity to prior probability. Did you read the Kahneman and Tversky article? Yeah, great. I'm glad you did. In this case, it belongs part of the representativeness heuristic. One of the things that the effect of the heuristic is that we have an insensitivity to prior probability. In this case, we should think most of these women are teachers and not very many of them are librarians, but because we have this insensitivity to that information, we just look at what we know about Emily. She's introverted. Maybe we think she's more likely to be a librarian. I kind of like this example because you can show the math with some charts. Let's look at these charts. I took this. This represents the set of all librarians, and the red squares are introverted ones. And you can easily look at this and say, oh yeah, most librarians are red. Most of them are introverts. If there's 100 librarians, 90% of them, that's where you get that. But what about the teachers? There's actually more teachers. Here's all the 900 teachers, and the introverts are red and extroverts are blue. You can look at this and see, yeah, actually most teachers are extroverted. Which one is Emily likely to be? Let's put them both together, and you can see that, you know, if all we know is that she's somewhere in this group of 1,000 and that she's red, you can actually see it's more likely that she's a teacher. Why? Because there's more red teachers than there are red librarians. So this is called insensitivity to prior information, but it's also called the base rate fallacy. So maybe I'd like you to know that one too. Maybe that's what Kahneman and Tversky didn't call it this, but people later on have called it this. So there's the conjunction fallacy and the base rate fallacy. Those are both instances where, because of the representativeness heuristic, we're making a logical fallacy. And so I don't have that much more time. Do you guys have any questions about? So here's some math that may be involved with the base rate fallacy. And like Peter said, Kahneman and Tversky call it insensitivity to prior probabilities of outcomes. That's what they called it. But the base rate fallacy happens when someone ignores the base rates, which is also the prior probabilities, and they just focus on the representativeness probability, which in this case was that, you know, Emily was 90% representative of librarians, but only what, actually 20% representative of teachers. And so because the 90% was bigger than the 20%, if you have the base rate fallacy, you think Emily is more likely to be a librarian. Whereas the true answer is she's more likely to be a teacher. I sometimes have my students learn the proper way to do this math statistically. I've decided this year I won't make you learn that. There's a formula in probability that you can use to calculate the probability that somebody belongs to some group given information about the representativeness of that group. And that's the name of that rule is, I'll just show it to you now, even though I'm not going to make you have to use it. It's called Bayes' rule. Bayes' rule is the sort of precise mathematical way to calculate what's called a conditional probability. The probability that something is true conditional on some information that's relevant in the way that Emily being introverted is relevant. So if you already know statistics, if you already know probability, it's really likely you already know Bayes' rule. Bayes' rule is simply the mathematically correct way to calculate conditional probabilities. What I want you guys to know is that humans don't do this. When we think about how likely something is to happen, we just don't use Bayes' rule. It's just too complicated. Instead, we use a heuristic. And oftentimes the heuristic is this one, the representativeness heuristic. And of course, I'm not literally saying every single person in the world uses the representativeness heuristic. And that's not what Kahneman and Tversky are saying either. They're saying there's a large class of psychological phenomena that exist in a large group of people, usually the majority of people, that can all be explained in some unifying way by this one heuristic, which is the representativeness heuristic. It explains the conjunction fallacy. It explains the base rate fallacy. And it's not perfect, maybe, but that's their contribution to this science. You guys have any questions about the representativeness heuristic? We've done two. We've done anchoring, and we've done representativeness heuristic. There's one more, and that is availability. And sometimes I ask this. Let me stop share. About 10 more minutes. I'm going to ask a question in chat, and if you don't mind, do you mind answering? What is more common? The letter R appearing as the first letter in a word, or the letter R appearing as the third letter in a word? Which is more common? In the English language, is it more common for R to appear first or third? And just, give your best guess. I'm seeing a lot of thirds, a lot of firsts. I think slightly more people are saying third than first. Thank you for answering. You can also do this with the letter K. Strangely though, I've had very little success with K, and I'm not having much success with R. When I say success, I mean demonstrating the availability heuristic. So let's talk about the availability heuristic. Now, this is the final of the three heuristics. Third, because I feel like we're supposed to say first. You're exactly right, Daniel. You were supposed to say first, but you didn't. You said third. Okay. Why do oftentimes people say first in this type of question? Well, it's hard for you to tell, unless you can just imagine every single word in the English language, which nobody can. think, and then, think about how many of them have R as their first letter, how many of them have R as your third letter. That information is just impossible to get. It's just, none of us have that type of computing power. Instead, what do? We try to think of examples. We try to think of some way to just consider all the words that we've had experience with in our lives, and how many of them seem to start with R. How easy is it to think of a word that starts with R? I would say it's pretty easy. Red, rose, rum, right, real. It's just easy to think of words that start with R, because that's just kind of what we do. A lot of times, you know what alliteration is. You learn this as kindergarten. Like R is for what is R usually for? Rhinoceros, red, robot. Whereas when you try to think of words that have R as their third letter, it's just not as easy. Like, wait, R is third letter. You kind of have to go backwards and sort of think of two letters before the R, like car or tar, or I don't know, ear. It's just a little bit harder cognitively to think of a word that has R as a third letter than it is to think of a word with R as a first letter. And because of that, the word that Kahneman and Tversky uses, availability, because it's more easily retrieved in our memory, it's also more available to us in our cognitive selves. Just like these R words to begin with are very available to us, whereas words that have R as a third letter are less available to us because of the availability heuristic that makes us think things that are more available are easier to recall, are more likely to influence our judgments. And so we think something's more likely to happen if it's easy to recall. Something, and if we're making some judgment over how common something is, or how worried we should be about some event. If you're talking about a decision that you're making under uncertainty, of course you should be thinking about all the possibilities that could happen. That if you invest in, oh, somebody's waiting to get in. They just popped in right now. If you invest in, let's say, mortgage-backed securities that are subprime, imagine that, right? Subprime loans. That's a very dangerous asset. But what are you thinking about? You're using your memory to think about how many times in the past have I heard of a mortgage-backed security crashing so that its value becomes close to zero? Never. And so you believe that that's really unlikely to happen because of the availability. That knowledge, is not very available to you. And it can go the other way too. Plane crashes, for example. Whenever there's a plane crash, especially if it's in the United States, that makes people. It makes the threat or the dangers of travel in a plane very available, and they are less likely to want to fly in a plane. Even though maybe statistically you could argue that it's safer to fly somewhere than it is to drive the same distance. If you want to drive across the country or fly across the country, it's safer to fly than to drive. But because of the availability heuristic, the plane crashes are more available. They're more salient. You guys know this word, salient? It's another psychology word. I'm teaching you behavioral economics, but I've got to talk about the psychology. Today was like all about the psychology. This word salient is what psychologists used for just like it's like how much it's in your consciousness, like how readily you're thinking about it is how salient something is. So if there's a plane crash and like it's big news, that becomes really salient, and therefore it affects your judgment of how likely there's going to be another plane crash. I think this one may be the hardest one to define, availability heuristic. It's the last of the heuristics. So let me just give you what are some other examples? I know the one I know one they gave you in the paper that Kahneman and Tversky's. I've lost my cursor. Cannot curse. Okay. Oh, sorry. Yeah. Hmm. I'll try to answer you in a bit, James. Um, the availability heuristic. Okay. One more example I want to give you from the Kahneman and Tversky. If you've read the paper, you've already heard this one, which is imagine our class. It's not that big of a class right now, but is it? Are there more ways to form groups of two people in the class? Like how many groups of two people, pairs of people can we find? Like Grant and James is a group. Grant and Peter is a different group. Grant and Emily, that's a different group. Each different possible group of two people. Are there more ways to do that? Or are there more ways to make groups of 10 people? You could take our whole class and form a group of 10, like the top 2 rows in my Zoom meeting right now, that could form a group of 10 people, or you could change it out. Which is, what are there more ways to do? Form groups of 2 or groups of 10? If you've read the paper, you already know the answer to this. And if you don't want to answer, that's okay. This is supposed to be another example of the availability heuristic, and you may or may not buy it, but I'll give you their argument is that it's easier to imagine a group of 2 people than it is a group of 10. And because of that, it's more available. And so the availability heuristic leads you to believe that things that are more likely, so easier to recall and more salient are also more common, more likely. So here's the example of my definition. Darn. Definition of availability heuristic here. It's when you're using examples that come to mind easily when you make a judgment or decision. And I gave you this. I actually gave you. I didn't give you this economic example. I gave you the other one. But let's say there's one where there are high-profile crashes. You're less likely to want to invest in those sorts of financial investments. Why? Because it's the crash is what becomes available to you, more salient to you, and therefore you believe that it's more likely to happen as compared to other things which are less salient, less available. So this one's probably the least relevant for economics, I would guess. The other 2 maybe are more representativeness heuristic and certainly anchoring. I would put anchoring as one of the biggest heuristics and biases that affect how people behave. I don't think there's anything else I really wanted to say on heuristics and biases. It's kind of a short section because it really is psychology. It's not even a very economic. I'm posing this to you in your reading response that's due Wednesday. I want you to think about what are some ways, and maybe some real world ways, that we could be affected by these heuristics and biases. And you can choose any one of the 3. You can write about availability, representativeness, or anchoring. But just think in some way, use your own words, your own example of how maybe we're making some kind of economic decision, any kind of decision that we're making that's affected by this judgment using biases and heuristics. So I'd like you to do that for Wednesday. And also, we'll have our quiz. We'll have quiz 2 on Wednesday. Before we stop talking about this, are there any questions about these 3 heuristics? There's videos for all of them, and let me just remind you: it's anchoring, it's availability heuristic, and representativeness heuristic. So, for the quiz Wednesday, I could ask you about any of these 3 biases and heuristics. Just it'd be good for you to know what they are, or maybe I'll give you some example and say which of the three heuristics could best explain why people behave in a certain way. So if it's something that really makes it sound like people are overestimating the probability because, A is really representative of B, very, very similar. Something about the problem where I'm estimating the value of this asset, and it's very similar to these other assets, and therefore, because of the representativeness, I think that it's very likely to belong to that same class of assets. That would be the representative heuristic. But if it's more like, here's your first piece of information that you've been told about this asset is that it has a value of something or a price of something. That's more of an anchoring argument, right? That you've been anchored to a price, and that affects how valuable you think it is, rather than telling you that it's similar to this other group of assets, and therefore it's likely to be. That would be represented. Those are almost similar. I'll have to word these questions in a way that it's not ambiguous. I'll try my best to make it so that you can tell. If you know what these biases and heuristics are, you can tell which one it is that I'm talking about. But then I could also ask about the stuff from the last few lectures as well. But do you guys have any questions about these three biases and heuristics?
You're going to post the final question or topic list on Blackboard, right?
Yes, I will.
Okay.
Guys have any other questions? I mean, I will I'll stop recording, and